Welcome to Full Steam Ahead. This is our lunar module. I'm Hex Rang and I'm a staff researcher with the Space Exploration Initiative. And I'm here joined by Becca and Rachel, who are part of our team at To the Moon to Stay, which is MIT's larger project to bring a payload to the moon with Blue Origin by 2024. So I'll let my friends introduce themselves and then we'll go into a little bit of a discussion about why we're going to the moon and some important questions that'll help frame all the activities that we've started for you.
Thanks, Mahek. Hi, everyone. My name is Becca Browder. I'm a second-year master's student at MIT studying technology and policy in aeronautics and astronautics. I'm also the lead student on the project that Mahek mentioned before with MIT sending a payload with Blue Origin to the moon.
Hi, everyone. I'm Rachel Belisle. I am a second-year graduate student in the Harvard-MIT Health Sciences and Technology program. My degree is in biomedical engineering, but my current research is in human spaceflight.
Great. So just to get this conversation started, I think we should give some historical framing to this project. Can we talk a little bit about the Apollo missions, when the last time we sent humans to the moon, and why we haven't sent anybody back since then?
Sure. So the last time humans were on the moon was in 1972 for Apollo 17. So it's been just about 50 years since any human has stepped foot on the moon.
Wow. And I think 12 people have been to the moon, right?
I believe so.
12 people have stepped foot on the moon. I think there are additional, because there were, six missions. So that means that there are also 6 pilots who didn't set foot on the moon, but have orbited. And then also the 3 people on Apollo 13 who orbited.
Wow. So I've heard a little bit about the NASA Artemis program, and it sounds like we're going back to the moon and sending humans back. Can you tell me a little bit more about that?
Yeah, so the Artemis program was announced, I think, about a year ago, and it's as you mentioned before, it's sort of like a new version of the Apollo program. It's named after, in Greek mythology, Artemis is Apollo's sister, so it's named after Apollo's sister with the idea that we want to send the first woman to the moon, as well as sending other humans back as well. So the timeline for that is it's supposed to be 2024, with given the current coronavirus epidemic that might be pushed back as development on all of the vehicles might be delayed. But that's the plan, is we want to go back to the moon with all of humanity, including women this time.
That's super exciting, but why should we be excited about going back to the moon as people here on Earth?
Well, it's really exciting to be going back because, again, we haven't been there in 50 years. So there's a lot of new things that we can learn by going again. Also, the moon is part of our preparation to go to Mars next. So we're going to be testing out a lot of the key technologies that we might need to go to Mars. And also very exciting about the moon is that hopefully this time we're going to the moon to stay. Can we keep a sustained human presence on the moon the same way that we do on the International Space Station right now?
Rachel, I know you do some of your research on human factors in space flight and living in space. So it'd be really great to hear your perspective on the challenges that we'll have when we're living on the moon.
Yeah, so I mean, we definitely want to keep humans safe and healthy while they're working on the moon. It's something that we already look at on the International Space Station right now. And so some of the problems are going to be quite similar to what we deal with now. So on the moon, we'll only have 17% of the gravity that we experience on Earth. And because of that, there's a risk of bone loss and muscle loss. And so right now on the International Space Station, astronauts exercise for about 2 hours every single day to try to maintain bone and muscle, to make sure that when they return to Earth, that they're healthy and they're not going to fracture any bones, etc. There's also this other field of research about psychosocial problems. So if you're in a really small habitat with a small crew of people, maybe 6 of you, you only see those 6 people every day for a couple months. We want to make sure that you're able to work well in that team and that mentally that you're staying healthy and you're able to perform the tasks that you need to during the mission. So psychosocial issues are also really important to consider. And something that's a bit more unique to the moon or a bigger problem on the moon is radiation. So the ISS is in low Earth orbit, so it has some protection from the Earth's magnetic sphere. But when you get to the moon, there's not as much radiation protection. So we need to find ways to protect our astronauts from radiation. So can we create habitats, for example, that have better radiation shielding? There's a couple different examples of that. I mean, I think Becca can also talk about these between the two of us. I guess we can continue the conversation about lunar habitats.
Oh, that would be great. Becca, what can we do with our lunar habitats to help solve some of these problems?
Yeah, radiation is a great question. It's definitely a big concern on the moon. As Rachel mentioned, the moon doesn't have an atmosphere in the way that the Earth does. And there's a lot of crazy ideas out there about how we can protect our astronauts from radiation. One of the ones that is my most favorite is mycelia, which is actually a fungus. And the idea is that mycelia actually has radiation protection characteristics just by like the way that it exists already. And so people have this idea that if you could build an inflatable habitat that has a shell on the exterior that you can put fungus inside of it and it will grow, and as it grows, it will not only inflate that habitat and make it structurally sound, it will also provide that protection from radiation through the mycelia being in the shell.
Wow.
There's another really cool idea. So there's lava tubes on the surface on the moon as well. So these are basically huge underground tunnels that were created by lava flowing through the moon. And so can we use these underground lava tubes to build our habitats, and can we use those as our radiation protection? So there's a lot of people looking into that. I think that's a really interesting option. And then also another idea, can we build with the lunar regolith, with the materials that are already on the moon, can we use those to build our structures and our habitats?
Why is it so important to use materials that are already there?
Well, we're limited on how much we can bring to the moon, right? So we want to kind of use what we have available, see how we can minimize how much we have to take with us, or the volume of things that we have to take with us.
Makes sense.
I think to add on to the radiation habitat, there's also some, astronauts will have to leave habitats at some point. So there's also research into what radiation protection we can provide to spacesuits. And this is something that our lab actually works on. One of our lab mates, Cody Page, who's a geologist, is doing research on how to add radiation protection to a suit. So her research looks at how carbon nanotubes can be embedded into the material of the suit to provide extensive radiation protection, and fascinating research.